Hello and welcome to this presentation about MLOps, governance and trust, where I will present how to deploy and run trusted AI systems at scale in the enterprise. My name is André, and I'm the Chief Data Scientist in EMEA at DataRobot. I joined DataRobot about 5 years ago, and I run a team of about 20 data scientists helping our customers build and deploy machine learning systems at scale. So before I start talking about MLOps, I will give a bit of an introduction about DataRobot. So DataRobot, we are a software company. We provide a platform that allows our customers to go from data to value end to end. So we provide solutions for data preparation, for feature engineering, for model building, and for model operationalizations, and then also to create AI applications that can be consumed by the business. So the problem we'll tackle today is the fact that a lot of AI systems and a lot of AI initiatives in the company doesn't provide the business value as it is rarely trusted in production. So 90% of organizations that have been surveyed by McKinsey cite obstacles to moving AI models into production. There are 84% of the data scientists that build the solutions do not even trust their own models once they're in production. And as a consequence, 70% of the executives have realized no value from AI despite large investments happening in the past few years. So how do you tackle these kind of problems? The answer to this is to actually have MLOps processes and standards in the organization. So MLOps is one part of our application, and I will describe like the main principles of it and provide you a platform demonstration. Basically, there are a lot of AI systems have a huge potential, but very low return. There are multiple teams who are involved in the process of deploying AI systems. So first of all, data scientists who are tasked in creating models like that can be then deployed. IT operations that are whose main goal is to operate those models and put them into production. The business are consuming those predictions and changing their business processes based on the results from the AI systems. The main challenges is that those three organizations are operating pretty much in silo today. So data science teams use a wide variety of languages, a wide variety of environments. They actually build custom solutions for different systems that they need to build. But when it comes to IT operations, actually, they don't necessarily like, the data scientists don't necessarily like and enjoy like going through all the governance and the IT processes that are imposed by IT themselves. IT, their role is to really ensure that those models adhere to policies and compliance, and that's everything that gets into production has a high degree of high standards of quality and trust. The business themselves need to have a certain degree of trust for the models that are in production. So if they can't trust the models, there is a high risk that the decisions they're making could potentially either be wrong or like could not potentially like not meet certain standards in terms of ethics, in terms of accuracy, and this trust here doesn't happen, and because the IT operations and the models that are in production are not managed and monitored in a proper way. So very often the business value is not generated. So this can create issues in actually realizing the potential value that you can have from AI systems. So these challenges is also a technology challenge. So the technology problem that we see most often is that many different departments go ahead and start to build models for numerous use cases and numerous languages and platforms. When the data science team is done, the issue is that first, the production team doesn't have the tool to deploy the model safely into the appropriate environment. And if the model gets there, they will be unable to measure the machine learning specific metrics such as accuracy or data drift across time once the model is deployed. When it comes to managing the lifecycle of the model, this poses more challenges to the operations team. It is common practice to run a champion challenger process to ensure that you're always running the most effective models in production. But this requires a specific environmental setup that is often outside the realms of what IT ops can provide. All of this was not enough of the challenge. There is also the governance and rules surrounding AI that needs to be met. This essentially means that the business just cannot trust AI in production. Organizations are often not even sure if it is better value than manual approach. Or the worst case scenario, AI is already in the production environment, but it is making poor decisions and opening up to the company to enormous risks. Here come MLOps, which is a product that DataRobot has developed. The MLOps platform is part of the DataRobot AI platform end-to-end and focuses on solving the problems with running AI in production and at scale. We're completely platform agnostic. You can run a DataRobot MLOps components wherever you wish. You can manage your AI models wherever you want them to run, and we can help you deploy your models in whatever language, format, or notebook they are created in. So in order to quickly gain visibility and control over your AI that is already in production, we simply install a DataRobot agent onto the environment, and immediately they are registered in the DataRobot, what we call the model registry. They are monitored for accuracy and data drift, two really important metrics to reduce the risk of AI in production. One particular challenge that I just talked about is the process to safely move from a model that is in development to production. This process becomes much more manageable with MLOps, as you can deploy almost any machine learning model to almost any platform. We can take models from wherever they are created and deploy them to wherever you wish to run them, all via the centralized model registry that you can also run wherever you wish. We can even assist in a multi-cloud environment to move models from one cloud provider to another. Once you are deploying models consistently via DataRobot, you can then choose to take advantage of the consistent API endpoints to make use of all of these models. There is no problem at all if some are running on AWS, Azure, Google, or even in-house on your own Kubernetes or Docker platforms. You will no longer be tied to a particular cloud vendor or their management tools. So there is also a model REST API that can be used in your applications to add real-time predictions right into your apps, just like many of our insurance or banking customers do during their digital loan application or underwriting processes. You can also use the same API for batch processes, like, for example, large customers who are forecasting their required stock levels every day when they predict their stocks. With all of your AI managed by a single platform, your machine learning and IT operation teams can have access to a single dashboard to monitor not only the performance and availability, but also for typical machine learning metrics, for example, data drift or accuracy. Then your business users can also log into the platform to quickly ensure the predictions they are depending on are accurate and can be trusted. They can even measure how much value is being driven by the AI by valuing the decisions made. But overall, they have the comfort that the specialist teams of data scientists and operations teams have the tools, information, and documentation they need to ensure the machine learning models are performing well with as little risk as possible and providing the most business advantage as possible. DataRobot MLOps is a single platform that unites all the efforts of your data science teams, your IT operations team, and the business consumers into a single AI center of excellence for your company to take advantage of the opportunity AI offers. So in the next part of this presentation, I will show a demonstration of MLOps, positioning myself into the feet of multiple of these users that might be consuming and using MLOps for deploying machine learning models at scale. In today's demo, we'll position ourselves as a financial services company running a center of excellence for deploying AI and machine learning models at scale, or as we call it today, MLOps. So we'll position ourselves in the feet of multiple users. The first one is George, our MLOps engineer. We also have Mary, our data scientist, and Mary and George work together to ensure they can build, deploy, and manage models in production at scale. And finally, we also have our loan approver and business executive, Aina. Aina is using and consuming a machine learning application that Mary has created. This application allows her to deny or approve loans during the application process, and she needs to be able to trust the predictions that are delivered by Mary's model. So let's get into the demo. George, the MLOps engineer, connects to his laptop. He sees a notification from DataRobot via Mary and clicks on it to look at what's happening. He'll see a history of notifications, automated notifications created by various events, for example, the deployment of a new model. This particular notification was triggered by Mary, the lead data scientist. Mary wants to deploy a home loan approval model, and she's asking George to review this model before it goes to deployment. George has asked Mary to update the importance level in a meeting earlier today. George then clicks on View Deployment, which will take him to MLOps, and in particular into the view of the model that Mary wants to deploy. MLOps provides a complete framework to fully govern all the organization's machine learning models. Users are assigned roles to review and approve different events, like creating a new model or replacing an existing model in production. George quickly checks the governance audit log. Like all deployments in MLOps, he can review a complete audit trail of all the events and who is involved. He verifies Mary updated the importance levels to high. He can then add a quick comment and approve the change. This changes the overall status to approve, indicating that the model is now production deployment. George decides to go into the Deployments tab in order to check in his other production deployments before logging out. The Deployments dashboard allows George to check on all the status of these production deployments, regardless of how they were created and where they were deployed. George is currently managing over 60 active deployments across different business units in his organizations. As George scrolls down, he notices that some deployments are done on cloud environments like GCP or AWS, whereas some other deployments are using their own DataRobot prediction servers. The dashboard also displays the importance levels so that he understands which deployments are mission critical. In George's company, some predictive models are created in a variety of languages and tools. Some of them are written in open source languages such as Python, Java, or R. Others are created via the DataRobot automated machine learning platform. Regardless of how they were created, George can monitor and manage all the models in a single place. Toggling over to the prediction health view, he can monitor the status of any of the deployments in terms of service health, data drift, and accuracy. George notices that the loan value predictor model deployed on GCP has a service health issue and it hasn't served predictions for more than a day. George clicks on the model to investigate further. This particular model was written using Java and was deployed on Google Cloud, the platform of choice for the marketing department. A DataRobot monitoring agent has been instrumented in that particular environment and is sending metric back to MLOps so that George can monitor this model. Clicking on the service health view, George is able to see metrics such as total predictions requests, response time, or error rates, so that George can monitor the service of this particular remote model. Scrolling down, he can see any metric over time. It definitely looks like this model has not served any prediction in the past few days. He clicks on the data error rate panel, and it definitely looks like a data error is causing the issue. In order to find the root cause, he segments by consumer. Those are the remote applications that are requesting predictions from the model. It looks like there is no issue with the West Coast server, however, there are issues with the East Coast server. It's probably sending unexpected data that the model doesn't know how to handle. Now that George has identified the root cause of the issue, he can make a call to the East Coast DevOps team so that they can potentially fix the data issue that is causing the error. Going back to the main dashboard, it looks like another model has issues, the loan default predictor. It looks like there is a data drift issue and that the accuracy has decreased by over 10% since it was trained. This is a model that was written in Python and deployed via a DataRobot prediction server. It looks like Mary is the owner of this one. George is not a data scientist, unfortunately, so he needs to get Mary involved in the troubleshooting process. Mary, our lead data scientist, logs into the MLOps application in order to investigate. She was suspecting something fishy was happening because she received a notification on Slack earlier today. Looking at her dashboard, we can see all the models that Mary owns. This is a subset of the models and deployments that George was owning because she's not an administrator. So she clicks on the problematic deployment in order to investigate. The first thing she would look at is data drift. Data drift typically is an early warning of issues that might happen with the model. This page shows how the prediction data changes over time from when she originally trained the model. On the chart on the left, we can see drift of each feature versus their importance. So each dot represents a feature in the model. The feature importance is shown on the x-axis, and the feature drift, so how it changes over time, is shown on the y-axis. It looks like the loan grade feature has drifted significantly here. So here I can just click on it in order to see in the chart on the right the range of values for the grade feature. The charts in dark blue indicates the original training data, whereas in light blue indicates the more recent prediction data. Mary notices that the model has not seen any grade E recently. Such a large disparity between training and prediction data can cause the model to degrade. By playing around with the sliders at the top, we can try to investigate when the data stopped having grade E. It looks like around June this year is the time it stopped. This page displays accuracy metrics for the model and compares predicted outcomes from the model to actual values. In this case, we're looking at loan default. Mary starts by investigating the log loss, which is an accuracy metric for the model. Today, it is worse by 22% as compared to the original value, which is really not good. From the chart, it looks like the accuracy started to degrade around July, which is about a month after the grade E disappeared from the data and there was data drift. It makes a lot of sense. By clicking on the boxes here, Mary can see and observe other accuracy metrics like AUC or KS or Gini, and they all tell the sales story. Looking at the bottom chart, she can compare the actual versus predicted over time. Here she sees that the model is fairly consistently over-predicting versus the actual. Next, Mary can click on humility to check the humility rules. The humility rules keeps the model honest. So what I mean by that is that those humility rules provide guardrails so that the models perform honorable actions when it's not certain or sure about its predictions and unusual events happen. In this case, Mary previously created a rule that overrides the prediction when it's outside the normal boundaries. So when it's outside 0.12 to 0.16, the model would override its prediction by the value of 1, which means that the loan is defaulting. Clicking on Summary, Mary can observe how many times the rule have been triggered over the past. And it seems that since the accuracy started to degrade, the rules have been triggered quite a few times. And this is actually a good thing. It works as a safety net for Mary. It's as if there was some sort of approval process working in real time every time the model was making a decision. Actually, in this case, Mary decides to add a rule so that we handle the case of the grade E disappearing in the data that was decommissioned, as we could observe in data drift. So what we'll do is that if the grade is not within one of those valid values, then it will automatically override the prediction to 1 so that the loan is declined. So now she can just add and submit the rule to her model. Given the degrading performance of the current model, Mary decides that it may be time to move it to another model, a new model, more fresh model, and so she clicks on the Challenger tab here. Challenger models are alternative models that can be tested alongside the champion model that is currently in production on the same prediction data. Mary has 2 Challenger models in that case. One was built in DataRobot automated machine learning. She's using that as a baseline, and the second one was built in Python. Looking at model performance over the entire historical data and historical prediction data, she can see that both the Challenger models would have performed better than the current model since there was the performance degrading. She checks other metrics such as KS and AUC, and she notices that this is still the case. So this is great news. However, Mary is a perfectionist and she wants to see the performance of a very newest model, and so she decides to bring another Challenger model. Clicking on the model registry, Mary can see all the staged models and model packages she has access to. She could add her model as a new model in the registry. But since she's built other versions in the past, she decides to register this model as a new version of the most accurate model currently in the registry. She clicks New Version and enters a description for this version of the model. So the next step is to add her inference code. So she could add her inference code from a local source, but Mary likes to use GitHub, and she uses the ability of MLOps to connect to a remote repository. So she selects the data science scripts repo in GitHub, and Mary is prompted to enter her branch and her commit number from GitHub. Let's have a quick look at Mary's GitHub account, and here we can see the code artifacts of the model that she version controls using her GitHub. She now grabs the path to her code and copies it to her clipboard. Back to MLOps, she puts the master branch and pastes the path to her code. Once the pull from GitHub is complete, we can see the details of everything that was imported into the new version 3.1 of the model. And now she gives a name to the version itself. Once the model package is added, it's easy to upload it into an environment to prepare it for deployment. In this case, we're using a drop-in environment that DataRobot provides out of the box for Python scikit-learn, but she could also very easily add her own environment. The next step is to test the model on a sample of data to see if it's ready for prime time. So she clicks on Test Model, and she uses the sample data that was already uploaded into the DataRobot AI catalog. She then starts the test. The test validates that the model is stable and won't run into any errors when it's making predictions. And once the test is successful, the new version is recorded here. Mary also has access to a complete history of all the tests that she ran with every version of the model. So Mary double-checks the tests that she just ran and ensures that everything is good. Now Mary can add the model into the model registry so that it's packaged and it can be used for be added into a new deployment. To add this model as a challenger, Mary navigates back to MLOps, clicks on the model that was problematic, and click on the Challengers tab. From there, she can click on Add New Challenger, and she can select the model package for version 3.1 that she just added to the registry. Clicking on Add Challenger allows her to add this new challenger alongside the other two challengers, as well as the champion model. So now clicking on Update Prediction, she can test the new challenger model on all the prediction data that was used. Mary wants to compare her new model with the other challenger to see if it has some better accuracy or not. We can see that the accuracy is pretty close. However, when she clicks on AUC, we can see that the new model challenger performs a little better. After looking at this, she's now confident that she can replace the model with a new challenger. So in order to perform this, she clicks on Replace and Swap Model so that she performs the operation. Following the governance processes, this change will need to be approved by George. Mary selects that this change is applied as soon as the change is approved, and she uses as a reason the fact that it's because of accuracy, and then she clicks on Accept and Replace. She is then notified that a change request was created. Going back to George, we can see that the change request is now pending in his dashboard. He clicks into the model, double checks into the audit trail. He then checks the audit trail and then clicks on Add Review. He then approves the model. The old model is now replaced, and Mary's new model version is now deployed into production. There was zero interruption during this entire process. This is what we call model hot swapping. Going back into Mary's dashboard, and now we can see that the new model was approved, and she can check that and see that all lights are green. Good news. She now can create a new application for her business sponsor, Aina, from risk management that she's been asked for. She clicks on Create Application and then selects the Predictor app. This is a web app that is providing an interface for the business and that is connected to the model to make prediction via an API. She then deploys the new application, and then she shares the application with Aina and she sends her a quick message. Aina, the business user who works in risk management, now checks her iPad to check the new app. She's with a client right now and she has a loan that she needs to approve right away. So then Aina uses the app to create a new record for the new loan application 22323. She then fills out the form with information specific to this loan application, such as a grade of C, an interest rate of 5%, and an annual income of 100,000. She then taps on Get Prediction. The app then tells her that the loan is only 8.52% of default, and it also gives her a set of explanations why this prediction was made. Each explanation is a feature from Mary's model that has influenced this specific decision. In this case, the purpose, the annual income, so the salary, the interest rate of 5%, and the term of 36 months have been seen favorable for this particular loan. So I really hope you enjoyed this demo. So if you want to know more about MLOps, you can visit our website, or you can also join the DataRobot community. So in the next few minutes now, I'll be answering the questions that was asked by the audience. Thanks for watching.
Thank you so much, Andre. We have one question in the Q&A. Would you be able to provide us with some use cases of when this has been successful for a client? How did it benefit their data prepping and building models?
Yeah, thank you, Liz. Yeah, sure. So I described basically some of the common use cases and then given a specific example. And then I will tell you what DataRobot can help with when it comes to model building and data prep. What the focus of the presentation, just to clarify, was mainly on our MLOps platform, which allows to expedite the model deployment, management, and monitoring, as well as all the governance, so really to scale machine learning and AI. But we do have products focused on accelerating model building and data preparation as well. So in terms of use cases, so I'd say the most common, we are very agnostic, but the most common industries include insurance, banking, healthcare, and manufacturing. Some of the common use cases are like churn modeling or patient journey optimization, or let's say marketing mix modeling, or optimizing campaigns, or potentially in manufacturing you might want to look at predictive maintenance. So those are common use cases. In terms of one big one would be in retail, demand forecasting. So that has been typically very successful in large retailers. To give an example, so we work with a wide variety of retailers, and in particular, I think one of them, which is one of the two biggest brands in North America of retailer, they have used DataRobot to replace some of their demand forecasting models. So the idea is that they can, if they are better at predicting demands at the store level, so for the different products, then they can also better optimize their stock and ensure that first it doesn't go out of stock, in particular in some specific events, but also that they don't put too much stock, which also have additional costs. What DataRobot was really able to do is to pick up patterns that were much more complex in the historical data and related to seasonality and events. And for example, on Black Friday, the accuracy at the item level of our forecast was 8 times low, like the precision was 8 times higher than the precision that they have in their previous demand forecasting model, meaning that the error was 8 times lower. It helped them really to optimize their stock, and the ROI of these kind of use cases can be up to 20, 30 million. So why DataRobot was used in that case was really to accelerate the construction and building of models on like dozens and thousands actually of article and items in the shops, and to create a lot of those models to actually capture all the patterns of data very quickly. So it's creating thousands of models in a very scalable way. And so what was used in that case was really our automated machine learning platform and automated time series. We also have a data prep platform that allows analysts to create data prep workflows very quickly. So that's from the acquisition of PackData, which is a data prep solution that we've acquired recently, about a year ago. As I talked about in this presentation, MLOps allows actually to deploy all of those thousands of models at scale, following standards and governance process, so that both IT, the business, and the data science team can collaborate and ensure that the models you put in production are top-notch in terms of accuracy, but also that if there are issues, you can monitor them and identify them before they happen.
Wow, very powerful. Thank you so much.